Is it out of battery or something?
Oh, really?
I don't know.
Does the laser work?
That's a very good point. Which one? So that must be the laser. No.
No, batteries are dead.
That's annoying. We don't have any spare, do we?
Nope.
I mean, I'm happy to drive.
Yeah, I'll have you drive, but I'll see if I can get some more batteries from the.
Sometimes when I remap stuff, I think I'm really clever, and then sometimes I'm really stupid.
Session reporting problems. Okay. I put in a ticket. Somebody hopefully will bring some batteries. What? So much for my surprise sign. We'll give it one more minute, then we'll get started. People are still trickling in.
Well, okay, so they are on a PDF.
Okay.
And I have the browser set up also just in case.
Okay. Then we're good to go.
So,
You done tweeting?
mm-hmm. It's important you does it.
Must tweet. Okay, so do you want to say something to start?
Mm-hmm. Hi all, welcome to the Plus BOF. It's Thursday morning, it's 1.5 days left to go. Woohoo! So thank you for all coming this morning for the first meeting after however many breakfast meetings you did or did not manage to have this morning. I'm Natasha Rooney, I work for the GSMA, I'm one of your co-chairs. I'm here with Aaron Falk, who's another one of the co-chairs, obviously, that's kind of an obvious. Blue sheets should be going around, please sign them. Or not sign them, put your name there, so it signs it illegible. Elliot's our Jabber scribe. He'll be coming to the mic with any Jabber questions. We do have a scribe as well. Who's our scribe, Aaron? Who's our scribe?
We've got 2 minute takers, Tail and Kyle.
Cool. Brilliant. Thank you so much. Please do remember this is going to be a heavily, a heavy BOF. We'll have a number of people at the mic. Please do say your name slowly and clearly for the scribes so that they know what to put in the minutes. It's very, very helpful. Cool. All right. So we'll crack on. We've got a number of things to get through. There is a detailed agenda in the for this BOF in the IETF agenda, IETF 96 agenda list. So please check it out if you can see it. Aaron will go through it in a minute. Cool. Are you ready? Excellent.
To make the preview the active window, or this won't work.
Preview the active window.
There we go. Okay, yeah, that works. Okay, hi, my name is Aaron Falk. I work for Akamai. Natasha and I are going to be sharing this. And some other people that you'll see this morning are the proponents for the BOF, Ted Hardy, Nuria Kunwald, and Brian Trammell. We're going to also have another presentation from Joe Hildebrand. Spencer is our responsible area director. Spencer, you here? Wave your hand in the back, over there. Today's agenda. After a few introductory remarks and a preview of the hums that we're going to take, we're going to have a discussion on motivation from a few different viewpoints. The enterprise operators, mobile operators, and an architectural viewpoint. After that, Brian's going to come up and walk through the technical proposal. Then we're going to have some time to talk about the charter, get feedback on that. And that's pretty much the story for this morning. So this is a working group forming BOF. This isn't a legislative body, right? The idea here is not to approve the specific set of words, but we do have a written charter that's in the agenda that we want to get feedback on. And so the idea here is to get some discussion, some feedback as to do people understand what the need is that motivates this work, what is the work that we're proposing, and we want to figure out whether there's a community that's energized to do it, and if there are any IETF or other critical showstoppers or technical concerns that should prevent us from moving ahead or otherwise shape the charter. Things that we're not going to talk about today. We're not going to talk about the specific implementation details, specifics of the protocol. This is conceptually a follow-on to the SPUD BOF, which was I think it was 2 IETFs ago, maybe 3. That was a prototype that's not something that we want to talk about today. It informed some of the thinking, but I think what we want to do is focus on what is a slightly more abstract discussion that's behind Plus, and any other rat holes in the opinions of the chairs. So here are the consensus questions. You'll see these again at the end of the meeting. Do people think that the problem statement is clear? Is it well scoped, solvable, useful to solve? If you're in the quick BOF, you may have seen these same questions, which I believe were plagiarized with permission. I think you can do that. We want to figure out whether there are people in the room who want to contribute to documents to move this work along. And then finally, we want to get a sense as to whether the folks in the room believe the IETF should form a working group with the charter that we've discussed today. And I've got sort of a bulletized summary of the charter. If you want to read the actual text, as Natasha said, it's in the meeting agenda and has also been circulated on the mailing list. So that's it for me. At this point, ask Joe Hildebrand to come and stand in the beautiful pink box. Joe, come and get the remote dingies here. There you go.
Good morning. Is mic working?
You have to get really close to it.
Really close to it. Really close to the mic. Is that better? All right.
Much
better. So I'm going to talk a little bit about some stuff that's probably obvious to a bunch of people in the room in terms of how firewalls work. The intent of this is not to push the state of the art forward. The intent of this is to just review what current firewalls do, so that we have that sort of paged into our mind, thinking about it as we're talking about some of the other things that will come up. So for TCP, when the firewall sees a SYN and the corresponding SYN ACK, it creates a little bit of state associated with that session. It looks at the TCP protocol, make sure it's well formed, make sure the checksums are right, etc. And one of the things that it's doing in this is ensuring that both ends of the conversation are able to both source and sync traffic. One of the reasons for this is to try and prevent some of the off-path and asymmetric DOS attacks that we've seen. Once that connection is up and there's some state established, according to whatever other authorization policies you might have, further traffic is allowed in both directions until the firewall sees either a fin or a reset in either direction. And then there's some extra timer stuff that happens. The intent is that the firewall will usually try and provide better than just matching the 5-tuple in order for doing these authorization checks. In particular, it will look at the TCP windows and use that as look at the sequence numbers, make sure the sequence numbers are in window for some value of sort of close enough. And so that provides a couple of extra bits anyway in terms of protecting from off-path attacks. So you don't just have to guess the port numbers, you also have to at least play with the sequence numbers to be able to get a packet in through from the outside to the inside. This wasn't necessarily designed behavior. We didn't really have firewalls when TCP was created. And so a bunch of the signals that we use for this stuff are implicit. So the resets that when the firewall is sort of shutting down the connection for whatever reason, if it sends resets, those are not really a design part of the protocol. They're based on spoofed addresses, and there's not much that one of the endpoints can do to figure out if those were from the other side or from something in the middle. There's also a bunch of ICMP stuff that some firewalls can do in this space, but none of that's as widely useful as one might hope. All right, so on the UDP side of things, there's a lot less going on. Same kind of session state startup where I've got a packet going from the inside to the outside that creates a little bit of state. We set a timer and we allow traffic on that 5-tuple back as long as you keep sending things from inside to outside. A bunch of the stuff that the TCP side was doing isn't possible in this space because not only are the transport semantics not visible to the path, none of the other things that come along with TCP, like the better than 5-tuple kinds of checking, et cetera. There's no way for either endpoint to figure out what the timers are. The default's usually 30 seconds, but it goes less than that in a lot of places, as we found doing media things over the years. We do have a variety of mechanisms for opening up pinholes explicitly by doing things like PCP that we've done here at the IETF. There's a variety of those, and I would say they're not quite as widely implemented as I would like to date. Trying to do something on sort of in the protocol that was being sent instead of having a separate protocol for that might be one way to start to approach this. The important point here, though, is that as far as the kinds of protection that the firewall can offer against denial of service attacks, against unauthorized traffic, and against traffic being sort of bounced off of things inside and having that being a mechanism to open pinholes is limited. And this is one of the reasons why you see folks either rate limiting or blocking UDP on the network. It's not because these guys are just trying to break the internet. It's not because they're bad people necessarily. It's not because they're stupid. It's because there's particular attacks they're trying to protect their networks from. So there's a large amount of attack traffic, and we can quantify that over time. And the the research group that just got chartered is one of the places where some of that work might happen. Because the firewalls can't do much in this space, that's it. So it's the combination of a large amount of attack traffic with a large number of vulnerable services, usually inside an enterprise, that leads to this behavior. What you'd like to do for some kinds of UDP traffic is to be able to get back to at least some of the minimum things that a firewall can do for TCP, provide a little bit better than 5-tuple matching, and potentially do some explicit signaling instead of just doing inferential kinds of things where really all that path elements have to date are dropping, slowing things down, or sending resets in TCP, nothing similar in UDP, and ICMP, which mostly gets blocked. So the hopeful noise here, though, is that in the past, we've sort of done some of these things hoping that no middle box would ossify the thing that we just did, or hoping that somebody wouldn't notice and that the traffic would continue to flow until somebody comes along later and blocks it. And in this case, we've at least got a couple of firewall vendors who are paying attention to the work that we're doing, both with the plus ideas as well as what's in Quick, are contributing to the discussion, are implementing code along with the work that we're doing here. So it's a much more collaborative, we have the potential for a much more collaborative environment than we've had in the past, which is good news in terms of long-term deployability, I believe. That's it.
We'll pause here for some clarification questions, if anybody's got questions. I guess first clarification might be that the pictures that you're looking at, these are two pictures of the Brandenburg Gate, one of which is more restrictive than the other. Oh, thank you.
Checkpoint Charlie on the
Checkpoint
left,
Charlie
Brandenburg Gate on the right. The joke here is right now it's tough to get anything through at all because we have no good way of doing authorization, whatever. The hope is that, hey, we will be able to get some of this UDP traffic through and on a more ongoing basis.
Hi, this is Daniel Kahn-Gilmore. I had a question because I didn't understand one of the points that you had made about what the firewalls do. You had said that they are checking the TCP window as a way to protect against on-path attacks. My understanding—
No, off-path. I may have misspoke.
Okay, thanks.
Sometimes when I speak quickly, yeah.
Jana Iyengar, are we only doing clarification questions for now?
I can't hear you, John.
Jana Iyengar, only clarification questions.
Yeah. Okay, thank you, Joe. You go stand in the pink boxes.
I'm Natasha Rooney again. Not with the chair's hat on. I'm gonna have to hold this, aren't I? Yes, with an individual's hat on, not a chair's hat on. I'm Natasha Rooney. I'm going to talk a little bit about mobile operators, possible involvement, uses, needs for some of the things that may turn into technologies in this group. And we'll go through a bit of things that have been happening in the past and some things which are still going on and how this needs to evolve or how this could evolve. So first of all, I want to talk about network resources being scarce. I'm going to be selfish in this presentation and talk only really about mobile operator scope. It's what I understand. If other people have other network situations they want to discuss, obviously that's fine. For us, spectrum is probably one of the big things which is scarce. Actually, I did some research in this when we were looking into Plus as a new technology as to how scarce network resources are. And it turns out in lots of cases, at least mostly in the Western world, at the moment, a lot of mobile network cells are being over-provisioned. So it turns out that in one mobile network cell, you'll have more users that are provisioned to use that cell than we actually have capacity to support. So you can argue in some cases that this works for now, today. You know, not everybody is going to be attached to a cell at one particular time. But what's interesting is we know that this is going to change as we move forward. We know with the IoT, I hate that, but the IoT cases, it does mean that a number of devices are going to be added to the network and we're going to have to carry them. And yes, you will use Wi-Fi for your fridge. You ain't going to stick a SIM in a fridge. That would be ridiculous. But there are some things outside that will need to have SIMs in it and will need to run over the mobile network. So because mobile networks suffer from this lack of resources or resources being restricted, mobile network operators do try to do things to solve this. They try to make the best use of their resources. It's natural. They want to be able to save money so that they can go ahead and provide services to their users. Now, this is not a new thing that we've been tackling here in the IETF. In almost a year ago, we held the Manu workshop in September in Atlanta, and we had the Accord BOF in the last IETF, which was looking at some of the issues that we face now with the internet as it is today, with a number of layers being encrypted. This is a snapshot from a presentation that Kevin Smith gave from the Accord BOF, which shows that one of the situations that we have with mobile networks working with IETF protocols, particularly TCP. So I'll talk you through it just quickly. Again, some of the people at Accord probably remember seeing it. So for instance, between the user's device and the base station, whatever you want to refer to as a number of names, there's a lot of noise between there. You might be inside a building, so there's walls as well, and you're also moving around, which means you have this mobility issue. So noise and retransmissions here reduce throughput or create some variability in signal. Now, this variability will mean that a content server or an end server may attribute that to being a congestion, even though it's not actually congestion. It's a user moving around and interacting with the cell. It's attributed to congestion. Now, at the same time, what we find is that back on the radio access network, there will be a number of things that are happening to try and control this issue of the volatility of the radio access network signal. We have a couple of things which do retransmissions at a couple of layers, and also we know that TCP is doing retransmissions and doing congestion control as well. All these tend to get a little bit mixed up and don't always play very nicely together. So there's sort of retransmissions going back and forth on multiple different layers. So what mobile operators tend to do, not always, but they do tend to install a TCP proxy. This TCP proxy is a bit of middleware which will intercept the TCP and then go ahead and solve this issue by doing a number of things. Sometimes they do other things. So one of the other interesting issues that we were looking at and trying to solve and optimizing resources on the network is allocating resource by resource need. So this means that when you have certain types of traffic that have particular characteristics, we can put them into particular flows and give them everything that they need to get to where they're going to go. The way that we could do this, I'm going to say could, and I'll explain that in a little bit, is with something what we call bearers. Bearers are an allocation of resource per user. So when you connect to a base station, when your signal starts up on your device, you make a connection. You'll get allocated a bearer. The bearer will have a set of quality of service characteristics, and that will be assigned to you by the radio resource controller, which will know exactly what it's capable of assigning. We could use this for separating of flows, for perhaps loss sensitive and latency sensitive traffic. That is possible. The reason why we tend to not do that today is it's actually quite expensive to do it. Although I do know that some operators do it. There are some operators that have separate bearers. Most operators just offer a default bearer for data traffic and a separate bearer for voice, because you know how much we love voice. So voice gets its own thing. So once upon a time, or perhaps still now, mobile operators would look at this resource issue and do a number of different things, right? So one of the things we might do is look at the 5-tuple, make some decisions based on that of what we're doing. If we know that you're going to Netflix, for example, we can be relatively sure that you're streaming. Apart from me, I just look at the lists of shows on Netflix and then just add them to my list and never actually watch them. So, but that's another thing. We also do DPI. DPI is really quite interesting. You can do some really powerful things with it, but you can also do some really dangerous things with it. I've seen some really cool experiments, but we know how bad it is and we know how dangerous it can be. So, but it is something that does happen. We also have transparent proxies and caches. Transparent proxies and caches save a lot of money for network operators. They save a large enough amount of money that we don't have to incur that cost from users. So it's within a lot of interest to continue doing that. Even if with encryption that high, it still makes some sense for some operators to do it. And as said, we still have those TCP optimizers as well. This is not an indication of what happens in every single operator, just a collection of stuff that I have seen happen in some. So please don't assume that every operator does this. Encryption is a sensible thing. It makes a lot of sense to do encryption. I'm not going to go into all the reasons. And it does make some of these things harder. What we're here to do is to try and understand, or what I'm here to do, not that hat, this hat, is how we can encrypt and make best use of network resources. So here's a list of things that are possible requirements or wishes, I guess, from this particular space. We would love to be able to give a flow of best balance of resources. We would love to be able to manage the networks resources sensibly and be able to future-proof those for all of the new pieces of technology and devices and capabilities that are going to come onto our networks as we go forward. We would like to be able to classify a flow for technical reasons, not for business reasons, for technical reasons. And we want the lowest amount of information possible. Believe it or not, I really don't care what you're looking at. Generally, this industry has given up on trying to know what you're looking at. We don't care. We just want a little piece of information that allows us to make some intelligent decisions about how to manage things on the network. We would like to trust in the trust model. And I'm going to jump just to the bottom one quickly. We don't want a trust model based on prioritization because we cannot trust that people on the ends are going to always tell the truth. And I have examples of that, not actually from this community, from a different community. But we need to be able to both parties trust that, or all the parties to trust in the trust model. And finally, we do not want to do any DPI or traffic inspection in this work. We want to be able to do these things without looking at that to preserve users' privacy and to preserve the nature of which is encryption. So I had a few things. I'm just going to skip. Oh, actually, that's it. So I hope that makes sense. I'll take any clarifying questions if there are any.
Jana Iyengar, I don't think I understand the last point about traffic prioritization. You did say it, but I still don't follow what exactly it means to have a trust model that's based on prioritization versus a trust model that's not based on prioritization.
Yeah, so I will give the example. So if you say, for instance, you've got traffic which is loss sensitive or latency sensitive, this is weird because we had this conversation before, but the idea would be that if you lie about that, it's not really in your interest. If you are loss sensitive traffic and you say that you are latency sensitive, you're putting yourself into a class of traffic which is dangerous for you. Your users are going to have a worse situation in that case. So why would you do it? On the flip side, if you did a trust model based on prioritization, so if you say, actually, I need a better service because I am real time, everybody would end up saying that. So that's what I mean by a trust model. It's based on the type of traffic that you are that best fits where you go. But also, this is a working group forming BOF, and that thing would have to be molded out. This is not a solution that I have. It's an idea. Echo.
Yeah, I mean, this last bullet point seems to implicitly assume there's an alignment of interest between the carrier and the person sending the data, and that is not obviously the case.
Sorry, say that again?
Yes, this last bullet point seems to implicitly assume that there's an alignment of interest between the person sending the data, the person identifying the data in a given traffic category, and the carrier. And that is not always the case. For example, carriers which desire to prioritize their own voice services over other people's over-the-top voice services, it's not in your interest to tell them by classifying your traffic as real-time sensitive that this is voice. So there's not necessarily an alignment of interest. And that makes it very hard to not have a trust model-based traffic prioritization.
Okay, so because they prioritize voice services, you feel like this is hypocritical?
No, what I'm trying to say is that there seems to be an implicit assumption in this presentation that it's in my interest for the carrier to know what I'm doing because then they will treat my traffic in the way I would like.
No, well, yeah, again, going back to what I was saying previously, I don't really care what you're doing. It's more about understanding how we can manage the network and get you from A to B in the place that you particularly prefer.
I mean, it's simply not the case that carriers don't prioritize traffic based on on what it is in ways that are adverse to the users. That absolutely is not the case.
Okay. I'm not sure.
Over here.
Yeah, go ahead, Elliot.
So let's try to restrict these to clarifying questions.
Yes, this is from Jabber. I think one of the persons is Sylvester. Sorry, I'm not eating the mic. This is from Jabber. It's from Sylvester is asking for a clarifying. It's a clarifying question as to what you mean by no trust model based on traffic prioritization. I'm sorry, that's the question.
No, it's okay. I answered that previously when I answered, yeah, that's fine. So if the person on Jabber wants to reaffirm, then write on Jabber and Elliot will ask again, but it's Jana.
Actually, I think Lorenzo was next on the other side.
Apologies.
Sure. Can you go back to the Mukashi slide? The one with the Japanese characters on it?
Mukashi.
Yeah, so, okay, so I think one thing here is one thing that I'd like to know, and I guess it's clarifying.
Is there a clarifying question?
Yes, because what I want to understand is how these things are used to optimize, because a counter data point that we have is Facebook had these measurements showing IPv6 was faster than v4, and we couldn't figure out why, and it turned out it was the transparent proxies making things slower. And so now those transparent proxies are now being upgraded to support IPv6, at which point they will make IPv6 slower again. So the question was, can you share a little bit more about which metrics are being used to optimize, and if there is transparency in those metrics?
Okay, so no, there's no transparency in those metrics. I've tried a number of times to get them, and it's near impossible in this industry because of commercial reasons, and that's just the way it is. But what I did say previously is that transparent proxies exist. I will say that they exist for a number of reasons, but in this particular case and the experience I've had, it more saves money to have a transparent proxy than possibly to improve performance. That is some of the information I gathered. I don't think it's as clear cut as that. I wish I could share. I've tried so hard to gather statistics on you to the point it always brings me to tears, but I can't. I'm sorry about that.
Trust us to do the best for you then, and tell us more so we can continue to do the best. Okay.
It's a contentious issue between two industries. I've said it multiple times. I'm here to try and create more collaboration between the two, as are a number of other operators that participate in IETF. So yeah, I'm sorry it's just not as clear cut as what I would like it to be. Jana, and then Chris.
Jana, can you go back to the last slide?
Oh.
So not a clarifying question, but I'm trying to clarify the point I was trying to ask earlier, and perhaps what Ekar was trying to say, but I'm not going to put words in Ekar's mouth. I think it's the third to last point, which is the ability to trust in the trust model is what mobile networks need. I suspect the general point would be that users also need to have the ability to trust in the trust model.
Oh yeah, it definitely needs to be two ways. 100%. Yeah, no, don't get me wrong. Maybe this just seemed
I'm
a
not
little
getting you
selfish.
wrong. I'm just clarifying that's
Yeah.
sort of the general.
So, we just the trust model thing has come up a number of times, and this is why I spoke to you about it directly. I think when we were in Dallas, it's very, very difficult. The example, and I'll give the example that I have in web. I used to be a web developer. In web, we have a thing in an API called Canvas, and in Canvas, you have the ability to. I'm pretty sure it's Canvas. You have the ability to start up the GPU by making something a 3D object. Now, websites like to use this even if they don't have a 3D object on their website because they want to start up the GPU so it renders faster. This all makes perfect sense. So what you find then is, and I've been to many a web developer conference, this was for some time an understandable thing that you just did. Even if you had a flat site, you just did it because you want the GPU to start up. So it wasn't really helping the situation. And that was a bad trust model that was in place there. I don't know what else they could have done to solve that, but that was a bad trust model. I've been in a number, I exist in this community and the mobile operator community. In that community, there is a lot of talk to saying we cannot trust what you send us unless there is a balanced trust model. So maybe what I should have said here was a balanced trust model, and that would have been more, a better way of doing it.
Natasha,
that would be a good thing.
So I think we should move on from here.
That would be a good thing.
By the way, thank you, Natasha, for bringing
I mean,
the
I
operators.
love it out here.
Thank you for bringing the operator's point of view here. You aren't an operator, but thank you for representing them.
Thanks, John. That means a lot.
Okay.
I think Ted's up next.
So clearly the meaning of clarifying in this community is to heat up and whisk until clear, just like clarifying butter. So it's my turn to be in the saucepan for a moment, and we're going to be talking about Alice and Bob and have a momentary diversion into architecture. Next slide. Wait, I get to do that. This is Alice and Bob, specifically that's Alice Cramden, played by Audrey Meadows, and that's Bob Barker. As you can see, Bob is in the listen state. Alice starts the conversation, and we get through the three-way handshake. We could go on with this forever. Indeed, I like old TV, so I personally could go on with it quite a long time. The important thing about this is that as I've displayed this, we were going through the endpoints giving each other transport state about their own transport connection, but not talking about the network in the middle. It's a big blank space. There really is a network in the middle. In TCP, all of the things that were just sent, the sends and the acks, et cetera, are in clear text. And as it turns out, devices on path can see that exchange at the moment, and they may act on it by adding state to tables, opening firewall pinholes, setting aside various resources. That's really the conversation that we heard from both Joe and in slightly more clarified way with Natasha. Now, the other thing that they may act on it by doing is copying everything to vast data stores. This isn't really a primary function of on-path devices, but it turns out that it's common enough that we worry about it. Enter encryption. So now that we know that this is a major problem, we're encrypting as much as we can. And to dodge that last bullet, we're encrypting both more data and more metadata. It's important to realize that transports being built on top of UDP are actually taking things that were transport state messages and moving them into the encrypted portion of the exchange. That leaves the other items that Ernestine, by the way, this character is called Ernestine, and why this isn't the canonical A, B, C, D, E, I don't know. Maybe it's just my own love of Lily Tomlin. Because the network elements using them were maintaining the path between Alice and Bob. So this is really the core thing that we're getting at here, is that there was an implicit layer in our architecture that we didn't really talk about. Those clear text messages were from Alice to Bob, but because they were visible to the path, they created a set of signals to the path element as well. There was an inference by those path elements that were being used to create and maintain state in the network, right? So this is kind of the core thing that we're here to talk about today. So that state in the network, that implicit layer, is now being impaired by the encryption of some of the transport state headers. We have some options. If we want to repair that impairment, we could use the internet layer facilities to send the signals we think are important. So we could use, for example, hop-by-hop headers in IPv6 to do this. They're not available, unfortunately, in IPv4 at the same level of richness, but these would be a possible way of handling it. There are some deployment considerations there that make that problematic, but it's definitely architecturally a reasonable solution to this problem. You could bolt these signals onto each transport. So each transport based on UDP or based on whatever upcoming transport protocols there may be could solve this problem for itself by creating a mechanism for...
Could you speak more into the mic, Ted? You're
Oh,
getting
sorry.
very soft.
By creating mechanisms for talking to the path. The difficulty here is that's a bit wearing, and there's a serious risk that the first one to do this well will end up having all the traffic shoved on top of it. We've seen this with HTTP and other things in the past, even though it might not be the right kind of transport for the real traffic. We could do nothing. So it's absolutely possible that we could walk away from this problem by saying, we're just going to leave the path impaired. The result of that is that whatever path inferences are made with whatever data is left may ossify or may be already ossified. We may be stuck with the fact that state timers for UDP, when it was being used as just a simple demux layer, are the state timers we have to use for every single transport we're going to build on top of it. And that's problematic. You could restore the implicit signal by encrypting less. Now, there are some people who might be happy with that. I don't know they're the people we want to make happy, but there definitely is this as a possible option. The other option, and the one that Brian will be talking about, is we could make that implicit layer explicit. So, clarifying questions. Get out your whisks and sources of heat.
Christian Uitema, Microsoft.
Louder, Christian, please.
Oh, I have to. Christian Uitema, Microsoft. Okay. Ted, when you mention layers, I'm a bit concerned because one view of layers is an onion that you peel. And I am, we have, that's it, I scared that stuff, you see? And when you have that, basically when you say layers, layers tend to translate into blobs of data that follow each other in the header of a packet. While a lot of what you want in the path layer is not so much having, I mean, we have tried in previously things like Shim6, for example, which were doing that kind of stuff, and have met with a resounding absence of success because people don't like to have this overhead. So when you say layer, it might be functions rather than layers, because most of those signals are signals that point in time in the communication that don't need to be present all the time.
That's certainly a fair point, and I appreciate the clarification.
Alain Durand, when you talk about making this explicit, we have a working group that has somehow explored that path in PCP, the Port Control Protocol, where the application will send a message to the first operator or middle box to open up a port or reserve a port. So there's some effort already in that direction, and I think it's a very interesting direction to go explore.
So I'm not sure I actually heard a question. Can you repeat the question part of what you wanted to say?
It was more of a comment than a question.
Okay, well, we're really kind of at clarifying questions pointed in this, but please hold the comment for later. Thank you. Tom?
So Tom Herbert. So I mentioned this on the list, and this continues to kind of bother me. Path layer, it has to be paths layer, plural. Every packet on the internet can follow a different path. The internet is packet switch, not circuit switch. The thing I think this is coming from is firewalls, which do have a model that they have to get a SYN, they have to get a FIN. They have to be in the path of all packets in the connection for that to work. But as we move forward, we're going to see more and more multi-homing, multi-path. Every smartphone is going to have a Wi-Fi connection to a mobile network. What we as applications are going to want is when we change networks, because we get a better network, we don't want to have to reestablish the connection because some device in the network decided that's not the path.
Tom, is there a clarifying question in here? 'Cause we're going to have time for discussion at the end, so.
So,
I think we should call it paths layers.
okay, so let me take it as a question of, is this model intended to be limited to a single path at a time? And I think that the short answer to that is no.
This is a clarifying question, Joe.
Joanna Kulik, Google. So I really like the way you've broken this out into thinking about it as an implicit layer that was existing before, and thinking about how we can make this explicit. And one phrase that I haven't heard come up yet very much is ossification. That's a big fear, and anything can ossify. I mean, the code can ossify in the middle box. The assumptions that the middle box is making about the transport can ossify. If we encrypt everything, the middle boxes will attempt to, make hypotheses about how everything is working, and those hypotheses can ossify. So my question for you, clarifying question, is: do you think that having this as an explicit layer will help with this ossification problem?
So I certainly think it's worth trying. So I think if we look at this and do nothing, the chances of ossification of the set of assumptions that are going to be made by the path is very, very high. But this is my wiping a crystal ball and trying to gaze into it a little bit. It's possible that the middle boxes could change with the onslaught of NFV to be much more quickly updated, and their inferences could change with path changes much faster than it does now. But my presumption as a BOF proponent is that creating an experimental method to do this and see if it improves the situation is the right thing to do. Clarifying questions from the back mic.
Stuart Bryant, could I ask where routing fits into this? Is it sort of above path layer, below path layer, or are you proposing to have a UNI introduced into the internet architecture?
So I believe that the routing system acts on the internet layer by using the internet layer addresses to move things to their destination.
Sorry, I didn't understand that. Say that again.
Okay. I would like to get through the proposal before we get further into the discussion. If you are still confused after Brian has given his, actually talked about what the proposal is, because this is just sort of about the architectural motivation, then we'll revisit this. And I'm going to cut the lines off now. So very quickly, 1 and then 2. Go ahead, Eric.
Eric Klein. So you think you said, is it the last slide, it says, should we make the implicit explicit? In your question here, is it just that this information should be exposed, or are you also suggesting that it should be modifiable at the same time?
I am not suggesting that it should be modifiable by the path, and if you listen to Brian's thing in a moment, you'll see how authentication of those headers takes place to prevent that.
Thank you.
Yep, Thiru, Cisco. I have a question. I mean, the previous presentation was...
I'm sorry, you're going to have to go way forward.
Okay. The previous presentation was talking about traffic priority. Okay. So this presentation is pretty clear that it's talking about firewalls to open and close pinholes, but the previous presentation was talking about traffic prioritization. So is it the BOF going to discuss both the problems, or just the firewall middle boxes problem, or traffic prioritization, which is a problem for both UDP and TCP as well?
I suggest that you wait until you hear the proposal.
I think the best answer for that is to bring up Brian, and for me to let him take over the dingus and the microphone.
I have one clarifying question.
Hi, I'm Brian Dremel. I'm going to make an actual proposal here. Actually, I like Tom's idea that this really should be called the paths layer. Although if you spell that wrong, it turns out to be paths layer. And it turns out that, yeah, you can actually use it for that, because what we're talking about is we're talking about explicit cooperation. And what do we mean when we say explicit cooperation? Endpoints and middle boxes cooperate today all the time. They may not think of it as cooperative because it's implicit cooperation. This is already widespread in the internet. Cooperation is when, the first time I thought of this as an explicit versus implicit cooperation problem I sent it to some mailing list, and Christian Huitema was like, implicit cooperation, that's actually kind of offensive. And he's right. It's the wrong term. Some of the hacks and the workarounds that are used in the network to actually make this stuff work are quite hostile, right? DPI is traffic classification because we want to be able to put something in one queue or another, so we're also going to read your email. That's hostile. The question is, can we reduce tension in the various tussles that have led to the widespread deployment of implicit cooperation? And our proposal is to make that explicit. So when we have explicit cooperation under endpoint control, and this is the only thing that we can do here at the protocol design layer, is to say that the control of what gets said is always in the control of the endpoint, right? The endpoint includes the transport layer at the endpoint, it includes the application layer at the endpoint. If those are well designed, it includes the user at the endpoint. When you do this, you have to have limitations on what you can say. The signaling becomes declarative and advisory, because so there was some chat in the Jabber room during Natasha's presentation that maybe this should be, we shouldn't be calling it a trust model, we should be calling it the honesty model, like the honesty bar in a hotel. You know, on balance, it's going to work out. You might get screwed occasionally. And actually, it's even better than that, because it's like the honesty model in public transit, like we have here in Berlin and many European cities, where there's no fare gate, you just have your ticket, you're supposed to have your ticket. Occasionally, we might check you. You know, 1 in 100,000 rides will get checked. And in the same way, many of these signals are also independently verifiable. They're not independently verifiable in a way that you can do it at scale on every single flow, but you can do sampled verification that the endpoints are saying things that are useful to the path, or the paths, when they declare things, are saying things that actually reflect the truth. Once you've got this explicit cooperation under endpoint control, these are things that obviously need to, because you're having signaling between endpoints and elements on the path that don't know each other, cannot be introduced, so you can't set up any sort of cryptographic context. Everything else goes into a layer above that anything that the path doesn't need to see, including the transport headers, which are needed for the end-to-end communication, but not for any operations on path, that gets encrypted. That prevents future implicit cooperation unless the endpoint authorizes that. So to the question of ossification, this is actually how we expect to solve the ossification problem, by changing the boundary, basically enforcing the boundary between network. I didn't advance yet. Oh, I know, I was just doing this. This is how we expect to solve the ossification problem, by moving the boundary of where the ossification happens and then encrypting everything else. So there are 3 basic mechanisms to make the paths layer explicit. There's sender to path signaling. So this is the sender of some traffic can say something about that traffic. There is path to receiver signaling under sender control. We'll get into the details of how that works later. If it's the sender that needs to know something and not the receiver, then there's a feedback channel so that the sender can know that as well. And then in the situation where packets are dropped, there's direct path to sender signaling. These are the old slides, Aaron. This is fine. Okay, pretend that these lines here are really bold to signify that the application and the transport are encrypted. So we have our 4 layers. We have the IP layer, we have path layer, we have the transport layer application. Transport and application are encrypted. The sender can see them because it has the encryption context in which they were encrypted. And then there's some information that the path wants to say to something along, or that the sender wants to say to something along the path. And it'll say, let's say it wants to say that value X is in, right? So value X could be, actually we'll get to a more concrete example later, but let's say here that value X is in could be, my sensitivity is to latency, right? As opposed to my sensitivity is to loss. Yay, bold. See, now we encrypted it. So now we send this on. Oh, and then, okay, so, and then there is a MAC on this whole thing that's actually exposed, that it maps the subflow, the X to N. It doesn't map the application and the transport layer necessarily because it's assumed that there's crypto on that that's taking care of the application and transport layers. Huh? Mike eating? Huh? All right. So we send this, a middle box sees it, it decides, okay, well, I'm actually interested in information about this 5 tuple, here's the subflow, and yeah, okay, I'm gonna keep track of the fact that for this 5 tuple in this subflow, the value X is N. Can't do anything with the MAC, can't see anything in the application, the transport. Depending on how the application and transport layer work, can't actually guess any of these things. When this gets to the receiver then basically says, okay, I have the subflow of the MAC DN, I actually can see the application, the transport information, I pass that up to the higher layer, and then it basically can verify that MAC. What it does with this on a MAC failure is actually up to the transport layer. In some cases, if this is just information that the sender is sending to the path that is advisory anyway, if something along the path is screwed with it, okay, that's fine. The advisory signal that I had didn't get sent correctly. In some other cases where you have a transport that really is designed such that it runs on top of this path layer, any failure of the MAC down here is actually a let's close the session or drop the packet or close the session sort of event. Here's how this would work for the very first sort of firewall use case. We have a thing that says subflow and there's a thing here that says start. So up in the transport layer, there's the equivalent to the TCP SYN. We don't actually know that that's there because it's encrypted. We can't see it, but we can see the subflow start thing that says, okay, well, I understand this signal. Yes, it looks like this subflow has started. Boom, I give that information off to the state table on the firewall, and things work even though the SYN up here is encrypted. And then, of course, then the receiver can do that MAC verification. Path to receiver is a little bit harder, and we didn't actually want to propose this until we came up with a mechanism to do it, because path to receiver under endpoint control is really kind of tricky. And the way that you do this is that the sender authorizes the path to say something to the receiver by putting a special key. So it says like, hello path, Y is equal to, here's some scratch space. And the Y here, the fact that this is a thing that the path is allowed to overwrite is implicit in the Y, right? So the example that I give is, I want to do a path MTU accumulation. So I'm going to say, okay, my MTU right here is 1460. I put this here. I say, this is the path MTU thing. Path, you are allowed to do things with this. When I MAC that, I fill that in with an empty byte array of the size of the data that the path is allowed to write. The path sees this, says, oh, okay, well, for this subflow, for this M, yeah, well, I know what my MTU is. I'm going to put that up in here. And then it makes it to the receiver. The receiver knows at this point that the sender authorized that information to be filled in by the path. It knows how much information, like how many bytes the path could put into the packet. So you can reduce the amount of entropy that you give to path elements here. And you have the MAC then sort of says, okay, well, nothing messed with this. It didn't get stripped off, or things didn't get added that weren't authorized by the sender. Sometimes when you're saying this, it's of course in the MTU case, it doesn't actually matter if the receiver knows what the downstream pass MTU is. It matters if the sender does. So then this would then generate sort of a path layer only packet back up to the sender, identified with the subflow, the MAC over this, and then the feedback would then be encrypted as well. Path direct to sender, this only works in the case of a middle box wants to say something to a sender about why a packet got dropped. So the packet gets here. The middle box doesn't actually know anything about this packet other than its subflow or anything that it might have said, so that it can essentially generate a direct packet that goes back with this key that says, okay, well, hey, I'm the path. I'm saying something directly to you, and this is why I dropped your packet. This can only work in the case of dropped packets, because otherwise this could be used for amplification and reflection attacks. So here's what we think the path layer looks like. We've got the internet layer. In the path layer, we have some UDP encapsulation with a shim where all of this path signaling stuff goes. And then we've got DTLS or some other crypto on top of it. I'm actually really intrigued by, from the quick POF yesterday, the TLS as a service thing that Martin was talking about. Looks like that actually might be able to build this in a way that we don't have the inefficiencies of layering that. So this is the advantages of UDP here is we get user space implementation, we get the ports so that we can get through NATs, and it's on the order of 95% deployable today. We get the encoding for signaling mechanisms lives inside that, and then everything above is encrypted. So there's been some discussion about this proposal. A clarifying question on these bits.
Clarifying question. You said in the middle, one of the three and a half mechanisms that you listed earlier wasn't really ready. Is your proposal to still do the 3.5 mechanisms that you listed earlier?
Yes, this is what we think is ready.
Make sure we weren't, you hadn't picked one of
One of the reasons it's taken us 2 years since the spud BOF is getting to this point. There's been some discussion on the outlines of this proposal on the spotted IETF.org list. I'd like to thank Mark Nottingham for this question. Is this just basically a user tracking and network neutrality violation machine? He didn't put it that way. He actually put it much more concretely and succinctly. But it's exactly what he meant. We all understood, Mark. And thank you very much for the question. You asked 3 questions. I actually turned it into 2 because the other 2 questions were just sides of the same question, I believe. Feel free to get up in the mic and correct me on that. The one here is, will it be possible for a middle box to use plus to insert user identifiers in the server-bound stream of a client-server protocol? And the answer is no unless the client specifically requests it. And if the client specifically requests it, then it can also expose other identifiers in the path, right? If the sending endpoint is basically at the point where it's colluding that much, then the game is over here. This is the reason behind having the MAC on path exposed information protect the presence of the key and the length of the data. Because a lot of the sort of the path accumulation signals that we're looking at are 1 byte, 2 bytes, 3 bytes long. And those are not long enough to do very good identifiers. You get more bits, but it's not like we're saying, okay, well, here's another 128 bits, or here's a GUID.
So I mean, I think that's technically true as long as the receiver enforces failure on MAC failure.
Yeah.
But if that is treated as advisory, you've just created, order 128 new tests, which can be filled with random shit.
That's a very good point.
Is that a clarifying question? And please provide your name. We're not going into the discussion period now.
Eric Priscorla, I don't know if it's a clarifying question, but it's clarifying the technical situation, which I think was important.
This is Daniel Kahn-Gilmore. This is a clarifying question. You're saying no here with a subsequent bullet point that says it's possible to do it today.
Right.
Will this mechanism make it impossible to do it the way it's currently possible to do it today?
No, but I don't think that's possible.
I agree, but that's why I think that no might be, that no makes it look like we're forcing it to be something that the client opts into, when in fact that's not the case.
Good point. The point is that we are not making it any worse, and we are not, through this architectural change, condoning that behavior. Right? This is, I believe, the best we can do. If we can do better, I'd love to have that discussion in a plus working group.
Clarifying question.
Yeah.
Joran Eriksson. This is about coordination between the endpoint and the
Name, please, and please speak up.
Oh, sorry. Joran Eriksson. This is about coordination between the endpoint and the mailbox. Right.
It's about the endpoint exposing information to the middle box, which is not necessarily coordination.
Okay. Exposing information assumes that the middle box needs certain, what performs a function.
Yes.
Right? You mentioned parental control as one example.
No. Did we mention parental control as an example?
Okay. Could you list the functions we expect the mailbox to do, and will we expand on that list in the future?
Is that a clarifying question for this presentation?
I don't understand if that's included in the proposal or not. Right? What's your assumption on the information,
So
the function the mailbox will do?
This proposal is about the mechanisms. I think we do need to have a discussion about the vocabulary which these mechanisms can use, and I would expect that to be a discussion within the working group, and I would expect it to be as small as possible.
Thanks.
Name, please. Christian.
Oh, he didn't go.
No, you said that. Christian, go ahead. Give us your name and
Christian
clarifying
Wiedemann.
question.
I love that. Christian, give us your name. Fine. Brian, do you have an estimate of the overhead of this shim method per packet?
So and I know that this is a rat hole that we said I'm not supposed to say, so I'm gonna look at the chairs when I say in the SPUD prototype, we were looking at 1, 2, 3, 4, 5, 6, 12 bytes of overhead per packet in order to do the recognition that this was a plus packet plus the subflow ID. One of the reasons behind that is the subflow ID needs to be a relatively large cryptographically random number in a relatively sparse space.
So we just jumped so down the implementation rat hole that I'm going to ask that.
No, it's the reason I asked
order of 10 bytes.
The reason I asked that is because, I mean, many of the transport protocol are counting by bits to make sure that we are not exceeding some threshold of overhead. So it has to be recognized that any shim kind of solution does increase that overhead by some amount. I wanted to quantify the amount.
Okay, great. I want to get through this presentation so that we can have the open discussion. So, Lorenzo, a clarifying question, please, after your name.
It is a clarifying question. Lorenzo Colidi, if you let me get to the end, the question is at the end. So, okay, so a good colleague of mine has a t-shirt that says IETF, designing should before how for 25 years. Now, the question is this.
I'm sorry,
you said,
the acoustics in here suck. Could you do that again, please? Designing
how before should for the last 25 years. Okay, so you said that this is a proposal. Did I get that right? This is a proposal? You're talking about a proposal?
Yes.
Yeah. The clarification question is, where is the problem statement? I heard some architectural things about path layer. Can we clarify the problem statement? Do we have a place where that problem statement is? Because you have a proposal, but I don't know what it's supposed to solve.
So the proposal here is supposed to solve two things. One of them is I'd like to be able to encrypt the transport headers and have the subset of TCP-like semantics that network operations currently use exposed to the path. That's sort of the minimal proposal. Beyond that, there are a few things that are currently done in network operations that currently either use DPI or ports in order to be able to classify traffic, in order to be able to characterize it. I'd like to be able to put additional information on the traffic under endpoint control in order to make those things work if the client, if the sender believes that they'll get benefit out of that.
Is there a separate document with that proposal?
Draft Kulavin SPUD use cases is the beginning of the list of use cases there that actually goes through a set of 9 use cases that we're looking at with all of the information that we see is exposed and how that interaction works. And I believe we also have in there information about how that would be implemented on path.
So the problem statement is solve these 9 use cases or something like that.
The problem statement is solve some subset of these 9 use cases because I can see that some of them are more implementable now. Some of them require more of these middle boxes to be in the network and are sort of phase 2. But this is why if you read the charter, we say we're going to start with these requirements which are derived from these use cases and these use cases, and then we're going to figure out which ones we actually want to solve in the working group. I suspect that'll be a subset.
Would have been great if we'd seen those use cases in the presentation.
Okay, the documents are actually referenced in the charter. Thank you for reading them.
So we're going to actually hold the rest of the questions until Brian's done with his presentation.
Can I just ask one clarifying question about what the drafts are? Where are which
drafts are? The drafts are listed in the agenda.
And in the charter. Draft
and the
Trammel,
charter.
SPUD, REC, draft Kulavin, SPUD use cases.
Okay, let's finish up.
Oh, I was getting ready to get to the bad news point, wasn't I? So the second question from Mark was, will it be possible to use Plus to require a client to insert a particular kind of metadata into a stream? And actually, there's no solution here. The bad news here is yes. The bad news here is, the worst news here is that there's a whole lot of different ways to do this. Actually, Ted and I sat down in Copenhagen a few weeks ago at a really nice pizza place called Mother. Some of you heard it right, may have gone there. It was the closest place to get to. And we sat down and we ordered a couple of beers and we ordered a pizza and we're like, okay, well, we need to have an answer to this question. And by the time that pizza showed up, we designed like 5 different ways to do this on path without having a layer. And if the two of us can sit in a pizza restaurant for 30 minutes and come up with 6, then I'm pretty sure that some of these are already running. What we think we bring to this with the with this mechanism here is the fact that that exposure, the fact that that key exists, is not just visible to that middle box, but to any other middle box along the path. And the receiver can verify that that key was put in by the client. So that improves the transparency of this pattern. Tom, you're over there, aren't you? Hi, Tom. Tom Herbert posted a draft list, draft Herbert transports over UDP, which is basically, hey, is it possible to make transport innovation work without explicit cooperation? We just take the path layer and strike out path layer and strike out everything and just say UDP DTLS. The point here is you make transport innovation possible. You use crypto, you break the middle boxes, and you call breaking middle boxes a feature. Yeah, you can totally do this. I note that this is 100% equivalent to Plus when neither endpoint decides to expose anything to the path, right? If you build this mechanism and you decide there is nothing in it for me by putting information into this layer, you just don't do it. That is a choice that can be made by the transport protocol. It is a choice that can be made by the application layer protocol. And I hope that the transport layer and application layer protocols that implement this make that choice visible to the user. Checkbox, turn it off. There's another question, can we use IPv6 extension headers? The idea here is we're saying we'd like to build this layer to be able to make talking to the path explicit. We already have that layer. It's IPv6 hop-by-hop headers. They've been there for decades. The idea, I mean, we're going to ignore IPv4, this legacy internet protocol, in future deployments anyway. It's going to take a while for this to deploy. There's 2 headers you could use here. You could use destination options, which are kind of architecturally unclean because you're saying, okay, well, here's a thing that the path is not allowed to look at. By the way, path, please look at this. You could use hop-by-hop options, which is that this is something that the path is allowed to look at and modify. And you would then use sort of the MAC tricks that we use in this mechanism on top of hop-by-hop headers. Another upside is that you don't really even necessarily have to go into user space because destination hops and hop-by-hop headers are already supported in most socket APIs. It's ugly as hell to actually use, but they're there. You can get the bits into and out of the header. The problem here is this is more impaired than UDP. This is from draft IETF v6 ops IPv6 EHS in real world. Thank you, Jen Linkova and Fernando Gont. If we're saying that basically we're at 95% with doing this for UDP on the web, which is the least impaired of these, we're at 89.5 for DO and 61% for hop-by-hop. So if we're saying that 95% is deployed enough that we can fall back from it, that's a thing that we can. That's a thing that I think that we can all sort of buy. But if you're falling back from something that was going to work 61% of the time, I don't think that's fallback. I think that's prayer. Can we use UDP options? This is draft touch TSV WG UDP options. The idea here is to add option space to UDP, and then we basically put all this path signaling stuff at the end. I don't necessarily know that these 2 drafts are trying to solve the same problem. And there's a big downside to this is that all of the stuff in the UDP options trailer has to be in kernel. So there's no way that you can do a user space implementation of this because it involves using the difference between the IP length and the UDP length to hide stuff from the UDP layer that the IP layer can see. It's a really cool hack, but it's not a really cool hack that I think we can use for this in all of the places that we want to use it. you'll notice here that in all of these slides, there's this little box, and in the box, there's path signaling. And the answer here is, do we need to choose now, right? Like the exact mechanism that you take this path signaling into and how we bind that, how we put that on the wire is not something that we have to solve today. So I think all of these are interesting. All of these are interesting ways to address the problem, but I think we don't necessarily need to choose exactly how that implementation works. It's the mechanisms, it's the abstract mechanisms that I think are important here at this time. To conclude and begin clarifying the butter again, there's some things we think we need. We need a mechanism for making the widespread cooperation that already exists in the internet explicit. We want to give control of this explicit cooperation when we make it explicit back to the endpoints. We want a clear boundary between what the path can see and what it can't, enforced by encryption. We want to design for this facility that we can deploy on the endpoints from day zero. And we want all of this without requiring honesty between the endpoints and the middle boxes. And with that, I defer to the chairs.
Okay, so we will take clarification questions on Brian's slides, and then we'll move into the discussion of the charter. And if you have comments on the work, I suggest you save them for the next section. Tim.
My name is Tim Shepard.
Yep.
Brian, there were several things on your slides that seem to imply, though I can't imagine you really meant it, that you might be adding a round trip time, one round trip to the startup of stuff.
No, I didn't mean that. What implied that?
You had DTLS there, and you also had a MAC.
Yeah, or
and
other
the MAC
crypto.
requires a key until you have the key set up.
Right.
You can't do the MAC.
Right.
So to me, they sort of implied that, oh, there might be a round trip, that extra round trip at the beginning to get this started. And in these days, I can't imagine you would want that. So
no,
that's the
we don't. So that's do we want to call that a detail? We have to figure that out, right? That is, so when we first started looking at this mechanism, the idea was that anything that gets exposed on the packets before the crypto is started up just simply doesn't have a MAC. And you can essentially expose it, and then you expose the same thing again with a marker that says, hey, I'm telling you this again, and here's the MAC. This complicates handling quite a bit, because if the middle box really needs to use that first packet in order to make some sort of decision, but the idea here is that in a lot of cases, especially for things that keep flow state in an environment that flow state may also be the beginning of a DOS attack, they already have this quarantine state. So the idea there is that you see the first couple of packets, it has non-MAC things, there's a mark, it goes into the quarantine state, it has a marker on the thing, and then the re-exposure later in the flow updates that. But that is a problem that we know we have that we need to work out, but the intention is to solve it, not to say, hey, you know what, 3 RTT is great, 4 RTT is even better. That's not what we're trying to say here.
I think Kyle's next.
Kyle Rose. So a clarification on the hop by hop header slide. When you say impairment, what do you mean by impairment? Are the packets dropped or are the headers?
Yeah, this is one minus the probability of packet loss.
Okay.
And so if you look at the draft, all of those numbers are 1 minus that, because they were talking about loss probabilities. But I wanted to put these in terms of, we said that it works 95% of the time for UDP. I wanted to put it in those terms.
Jana Iyengar. Can you go back to the slide that you had just before this? That one.
Which?
No, the one before this, the one with the, oh boy, I don't know which one's before and after now. The one with the Tom Herbert slide. Thank you.
Huh? That one.
That. Do I understand? I'm trying to make sure that I understand the slide correctly. Does this mean that one instantiation of what you're talking about would be that the endpoint effectively creates a shim with DTLS?
Well, so
and let me just finish this question. Yeah. With DTLS and with basically no information at all in there, and that would be a perfectly fine instantiation
that's perfectly fine.
of this protocol?
Yes.
Then my suggestion would be that you make this extremely clear and available which is, I think it's a very important point, and I think it's a very good slide to have because of that. That puts actually control back in the endpoint's hands.
Yep.
In terms of what they choose to expose.
Exactly.
Another clarification point. I don't think calling it implicit cooperation it's not accurate, and I feel like it's actually underselling or even undermining the real difference here between the proposals. The old way was co-optation.
Mm-hmm.
The new way that you're proposing is cooperation. That I think
I agree with that completely. Yes, that's a better way to put it. Thank you. Co-optation is hard to. Co-optation is almost as fun to say as paths layer, but yeah, that's a much better way to put it.
Tom?
Tom Herbert, the path
Could
layer.
you go back to the last slide for a second?
Which last slide?
The very
final.
last,
This one.
That one.
Yeah.
So point number one.
Yeah, you really got to swallow the mic, Tom. I'm sorry.
Sorry. Point number one and the last point. So you want to have explicit cooperation, or
yes,
as Jana said, cooperation without trust.
Yes.
I think that's going to be really hard to pull off. If
the way that we
you,
try to,
I don't trust you with my information.
Is that a clarification question? Let's try to keep focused so we can get on the discussion of the charter.
Are we talking? So this is still clarifying questions, or we're talking about the actual content?
we're still in clarifying questions on this presentation.
So, Jahidul Jaman Sharkar, clarification question, I guess. So, sorry for my lack of attention to these drafts, but I would like to know, does the client know who is sending the reply? I mean,
does the client know who's sending a reply?
I mean,
can you scope that a little more?
You send something back to the client, right? From the middle box?
Oh, this one here.
Does it know like who is sending me, and like there could be
that one here?
Yeah.
No.
No.
Not. So the problem is that here you'll notice here that's IP from the sender to the receiver. That's IP from the receiver to the receiver to sender. This is how you do NAT better than ICMP does. So the idea is inside this section here, you'd probably define it so it's like, here's my IP layer address, but you would need some sort of way that there's sort of a more identification here. So it's not in the framing, it would have to be in this, in the upper section, and that's something that we can define. So actually I'm going to change my answer, yes.
So
it was no, and then it was yes, because I just designed something while I was up here.
So that was definitely a
That's the point of a meeting. Otherwise, we can do it on the mailing list.
But the thing is, like, then there could be another middle box also sending same thing back to the client.
Mm-hmm. So the idea here, this only happens on a drop packet. So on a given path, you only get one of these. Obviously, someone can spoof that, and you need a way to keep that from.
So we're gonna cut the line at this point. So.
Right, but this is an issue we know that we have to get the details right on, and that's a thing for the working group.
Okay, thanks.
Have we cut the line, or?
We're gonna drain the queue.
Oh,
but not let it get any longer.
Joanna Kulik, Google. So I think this is a clarifying question. I'm having trouble in understanding how this is all going to work when it's just partially deployed or initially deployed. How do you envision that working? And I will express a slight fear, which is that if the middle boxes give preferential treatment to flows that have this marking in order to incentivize everyone to use it and expose information. How does it work when it's sort of still heterogeneous?
So actually, we think that phase 0 looks a whole lot like this. And the point being that you're now standardizing a way to use crypto to deossify everything that happens about the transport protocol, with a caveat that you want a very small amount of additional signaling. These are things that these are things that look more than like this here. Of course, on day 0, there's no middle box that knows how to understand that and say, hey, I've started. This part here is phase 2. This is years away, possibly decades. The idea is to define the types of things you'd like the path to be able to say to you so that when we get to the point that this happens, that there's actually already kind of something to deploy. In the middle phase, so phase 1, the idea is that it's actually, it looks a whole lot like Quick, right? Where you have a transport layer that most of its signaling is encrypted. Some of its signaling is out here, integrity protected, but not encrypted. And with the intent that middle boxes that want to play with that transport protocol ossify around that.
Thank you.
But we understand that we're talking about a long-term transition here.
Hi, this is DKG. Can you go back to the slide that had the good news and the bad news on it? Sorry, but I have a question about the bad news.
Yeah.
Yes, thank you. So again, this is you had said that you designed 6 other ways to provide this kind of bad news arrangement over pizza. Sorry, you said that you designed 6 other ways to provide this bad news over pizza, right? Yes. And the advantage of this is that this brings transparency to those other bad news ways.
No, this brings, if you use plus to do this, that's more transparent than the other bad news ways.
So the other bad news ways were non-transparent. That is, they were not visible to the
I have
user.
64 bits in my IPv6 source address that I can use to signal information to the path.
So we don't think that this actually solves the problem of non-transparent signaling.
Correct. Because that's not a solvable problem.
Lucy Yang from Huawei. One question. So this enhancement required all the endpoint as well all the middle box on the path to change.
For this form of signaling, you need at least one, you need the middle box that you care about to support it. But the point of encapsulating this in UDP is that for all other middle boxes, it just looks like UDP. So in phase 0, it's just the endpoints that need to support it. Otherwise, it just looks like UDP traffic. If it just looks like UDP traffic and there's no small additional information, then firewalls are going to work as well on it as they will on UDP. Phase 1 is firewalls support it. There are a couple of sort of pie in the sky use cases. You know, once you have this, if you do, there's some measurement use cases that are really interesting. You can do inline trace route, but that would require every middle box to change. So I don't think we're ever going to get there.
Dan Druta. First of all, I want to thank the proponents of this for the work and actually keeping the momentum on this dialogue. Because really, I agree with Jana on the statement that we have no implicit collaboration. It is actually more conflicting optimization desires that one is not aware of each other. The servers try to optimize for bandwidth on the hosting side, on the data center. The clients try to optimize it for bandwidth. So everybody's trying to do some optimization and they use metadata one way or another. So I would actually say that this is making collaboration happen for optimization reasons. Irrespective of what you call optimization, but being transparent is actually very important. The other thing is that I do support the idea that we do not want to base this on a trust model. It's actually the
I'm sorry, is there a clarifying question?
Yes, the clarification was to make sure that we're explicit on the fact that the trust model is not a trust. I mean, we don't base this on a trust model. Yeah, thank you.
Yes.
Muthu, the first presentation seemed to highlight that there's a problem with UDP. Then the second and your presentation seems to say that there's a problem with encryption. So I'm not quite clear whether it's a UDP problem or it's a general encryption problem. And if it's an encryption, if it's an issue with encryption, what kind of encryption? Is it TLS or IPsec or DTLS or something like RTP web data channel? So which one is actually causing the problem here?
I'm sorry, Eric, we've cut the line.
I don't see the clarification question in there. It sounds like we're already kind of open to everyone, because that's a question about the first two presentations, not about the.
Yeah, let's come back to that when we get to the open.
Yeah, let's come back to that one, because it's a good one, but I want everybody up here for that one.
Yeah, clarifying question. So is there some analysis done with the existing off-path techniques like?
Can you be much louder and a little slower, please?
So, Thiru Cisco, is there some comparison done with existing off-path security techniques like PCP because it uses explicit trust model between the endpoint and the firewall and
Right.
does not suffer the security problems that it has here. And
So
shouldn't there be a comparison done to see how this is beneficial and how would it get deployed much faster than the previous mechanisms? That
So
we get?
the big difference between what we're proposing in PCP is that this is in-band and PCP is out-of-band. PCP pretty much only works in the situation where you're on a single administrative domain, right? So that the incentive for signaling is you're actually talking to your own firewall pretty much. The idea here is that we can eventually get to a point where you're talking not just to middle boxes that you know exist, but also to middle boxes that you don't know exist.
But yeah, PCP does work across administrative domains using PCP proxies.
I'm sorry, can you say that again? The acoustics are really bad.
PCP works across administrative domains using PCP proxy. Yes, it does.
Is it deployed like that?
Yes, there's an RFC saying how it can work across administrative domains.
Okay, I learned something this morning because it doesn't look like you can actually set up the incentives for the signaling so that it actually works.
And one of the things that I see is there is always an authentication authorization between the endpoint and the firewall to open and close pinholes, which is like here any attacker could come and say close the pinhole. So how's the security properties being discussed with the existing mechanisms that are
Sorry,
there?
can you slow down and you really have to kind of, I mean, it's really uncomfortable, but.
Sure, sorry for that. Yeah. So PCP has security mechanisms to ensure that endpoint and the firewall has a mutual trust between each other, and only with that trust model, the client can say open close pinhole and it only signals to authorized firewalls. But in this case, there's no explicit trust between the two endpoint and the firewall. So how does it offer better security?
How does a TCP firewall, I'm going to reduce your question to a different question. How does a TCP firewall in a non-PCP environment know that it wants to open a port? And the answer is SYN.
Yeah.
If you encrypt the SYN, how does it know?
It doesn't know.
We're talking here about having the actual signaling inside encrypted with an exposure of that signal outside, right? So we're talking about like a fundamental, I really don't want to use the word paradigm. We're talking about a fundamentally different architectural pattern where the PCP pattern is I can establish some sort of relationship where I can give you commands. I can tell you, do it.
Right.
Here, there is no command. This is declarative as opposed to imperative. Here, the idea is, by the way, this is the first packet of my transport session. You might want to pay attention to that. That might be something that's useful to you, as opposed to open this port, I command thee.
Let's move on.
Thanks.
Thank you. Janet, you have another clarifying question?
No, I'm just.
We're going to give you a token bucket for future BOFs.
Will you also give me tokens? I'm just at the head of the next line.
Okay, I guess you're done, Brian.
So actually I have a clarifying question.
I'm sorry, we cut the line. We're gonna reopen the mic lines for the
okay.
discussion of the BOF.
I will
of
ask
the
it
charter.
on this one then.
I'm sorry?
I will ask it as a follow-up to one of the clarifying questions. I'll wait, but I'll
Okay,
ask it.
Great, let's move on. Thank you, Brian. You put up the charter slide?
I'm done. I sit down, or are we all coming?
You can sit down. That's why I said thank you. That was a indication to sit down. Let me be explicit instead of implicit. Please sit down. Actually, please stand up. Actually, why don't we have let's have the BOF proponents come up to the microphone, since you guys should be answering the questions rather than us chairs. That's okay. Well played. Okay,
This is the problem with imperative signaling when the signals get crossed.
Brian, you're not that tall.
So what I have summarized the charter elements in a few bullets because you can't fit all the text on a single slide. If you want to actually look at the text, it's included both on the BOF wiki and in the meeting agenda. But the fundamental elements here is that we're talking about a shim layer that's above UDP, that's implementable in user space. The objective is to support ubiquitous deployment of encrypted higher layer protocols. The goal is to have a transport independent exposure of TCP-like flow semantics to devices on the path. A second separable goal is to permit other explicit signaling to be exposed between the apps and the path. And finally, to enable devices on the path to signal to the sender under sender control. And so I think it's, I'm making these last three bullets, I believe, are separable goals, and I'm interested in hearing commentary on them separately if you find, say, some objectionable and others not. I think that's the kind of thing that we want to get surfaced in here. Look at the length of the lines, everybody. Please try to keep your comments on point. Go ahead, Jana.
Thank you. Jana Ingar. I would modify the third bullet to just say optional sender-controlled transport-independent exposure of blah, blah, blah. Because I think I believe that's accurate.
You're wanting to make the signaling optional, not the sender control optional, correct?
That's correct.
Okay, yeah,
But-
that's,
oh, yeah, of course.
it is optional.
Permits, I thought implied optional, but yeah, I don't think there's any disagreement there. That's the intent.
Right, yeah, the intent is that it's optional. The sender control part cannot be.
So I'll try to be very quick about this. As I understand this, this is basically, I am literally kissing the mic right now. So this is why I was at the head of the line. People behind me have to worry, not me. There is an end-to-end shim with the possibility, the option of adding information from the endpoints that middle boxes or the network might be able to read, and for the network to put in information which a receiver may read. I think that's a very useful way. It's finally clear in this charter and so on what exactly is optional, what's required, and so on and so forth. It's very good. I want to point out that there's something fundamental going on here that you haven't really pointed out. Traditionally, we've thought about solving problems end-to-end. I'll give you one specific example. Congestion control, bandwidth and rate estimation. There have been proposals, even at the IETF and in academia and various places, where middle boxes, or not middle boxes, but devices in the network have participated in this process through a variety of different means. XCP comes to mind, which is closest to one of the most recent proposals we've seen in the IETF, which is, escapes my mind right now. But my concern would be that we are going to be talking about those things, and we won't be talking about them as fundamental shifts or fundamental changes in the way that we do things. If the network expects the endpoint to signal its bandwidth requirements in order to forward packets, that changes the expectations that we have of the network. And that depends on what happens going forward, but this exposes that conflict or that tension in the future.
Ted Hardy, not speaking for all of the proponents, but for myself. I think that one of the things that you're pointing out is that there are certain things that people might request to add to the bucket of signals, which it turns out don't make sense. And so that the working group, if it were chartered, would have to make sure that it didn't focus on elements of signaling which the endpoints can't, in fact, provide useful estimates for or otherwise provide requests for. And I think that one of the reasons we're starting with TCP-like flow semantics is the endpoints are clear about what the flow semantics are. It knows when the flow is starting, when it is stopping. And that's, I think, the model, and Brian's comment earlier of what the registry of these signals would be, being as small as possible, I think is the model the working group would have to take going forward.
So I'll just clarify that easy signals are by definition easy. The reason I raised bandwidth estimation is because that has been a debate even in the academic community for a long time about whether you can do it end-to-end or whether you need network support for doing this. And it continues to be a debate here as well. And that is one of those things that is hard to resolve. It's not easy to say it doesn't make sense. But this will change that paradigm, which is fine. I'm not saying that it's a bad thing. I think we should be upfront about that is all.
Okay, thank you. In the interest of managing time, let me suggest that the proponents try to keep their comments to a minimum, because I think we know you've had a lot of agenda time, mic time already, and the goal here is to try to get as much feedback as possible from the folks in the room. So I'm not trying to cut you off, I'm just trying to say, be brief.
So I would like, that's the point I wanted to make the whole time already. The reason why we're not talking about more specific use cases here is because everybody would go to the mic and say, what about this use case? And you find a lot of use cases in the use case document. Each of these use cases have a own problem description, and they talk about which information you would need in the past, how the mechanism would work to use this information, and it's a separate discussion each time. So what we try to do here is to focus on the very basic use case, in which that is like firewall traversal for encrypted traffic, how to make that possible. And all the other discussions about use cases need to go into the working group on a base-by-base section, and we have to decide about each specific use case, which information to expose, does it make sense, do we want it?
I realized that I had another slide that I didn't show. I'm going to just show you the deliverables, because I think this is an important, couple of important points here that we haven't talked about yet. That the objective here is to create an experimental protocol specification, right? The idea, so to give the community a chance to try this for a while before we agree that we know it's a good idea. Of course, we need to consider the vulnerabilities around this, and I think that some of those have been already raised. We've mentioned a couple of times that the working group is going to produce the vocabulary. There'll be a registry that will be, controlled in using IETF processes on what kinds of things can be expressed in this shim, and then the focus is, of course, on implementations and on integration with existing UDP-based applications that we think will be able to take advantage of this, notably WebRTC and Quick. Of course, it can be extended to TCP, SCTP, blah, 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 PPP, and my cat. So just, again, just to cut the conversation, what we're talking about here is producing an experimental specification. That's one higher bit, and the other one is that to use IETF processes for the registry of the kinds of things that you can communicate over this channel. So let me go back to the charter scope, and yes, go ahead.
Alain Durand. When I listened to the first presentation this morning, it was not clear to me that this was going to be only about inbound signaling as opposed to outbound signaling, and that seems to be really the defining feature here.
I'm sorry, can you clarify what you mean by in and out? We've been talking about endpoint and path.
Inbound because...
Oh, in-band.
Inbound versus out of band. Well, things like PCP are out of band. So in the IP architecture, we have a lot of things that are out of band, like the ICMP messages and all kinds of other things like this. So this is almost changing this overall architecture by bringing everything inbound. And I think it would be worth thinking about how is this going to change overall, and how this is going to impact other things. And you may have conflict. For example, if you have some ICMP messages that have the same semantic as some of the options that you will put in there, and you get conflicting information, what do you do?
Do you guys want to reply? Or no? Okay.
Unless there's something important.
Exactly. Let's keep going. David.
David Black. I heard Brian talk a little bit about phases. Brian, how does your discussion of phases relate to scope of the working group and initial target? What are the phases, and how much of which phase has to be accomplished in order for the working group to declare initial victory?
Good question. So, actually, there are two ways to answer this, and I think I'm going to answer them both. Sorry, Aaron. Hello. The first one is that we actually, so the basic idea is that we're explicitly fixing the ossification problem by reossifying, and we get to do that once. So when we talk about phases, we talk about how we expect deployment to go. And I think that we want to be in a situation where we define a system that either supports all of these interactions or supports exposure in a way that we could define the other interactions later. But we don't want to be in a situation where we say, oh, well, we want to go ahead and wait for one middle box and sort of like edge router replacement cycle, which is 7 years. And we want them then to be able to listen to these signals. And oh, by the way, it would also be nice for them to say things to us, but oh, we didn't design that. So the reason that we have sort of this comprehensive mechanism here right now is that we think we only get to redesign it once. When we talk about phases, it's not phases of the work of the protocol design, it is phases of the deployment.
Subodh Iyengar. So what happens when we get—
Can't hear you.
Oh, Subodh Iyengar. I'm kissing the mic. What happens when we get to like phase 2 and there are protocols which will explicitly never send the SPUD signal? Is there any worry that, so I'll just complete the question for a sec. Is there any worry that middle boxes will treat these protocols as suspicious, or like because they're not signaling their content, they're suspicious and start blocking the content like they do now for UDP traffic, but even more so because they have a license to do so now?
So in some of these networks, all UDP is suspicious now. And yes, there is certainly a potential for any markings that you expose to the path to be misused, right? So part of this is going to be also a learning process of getting the incentive structured correctly so that operators understand the consequences of misusing any markings that are put onto these things. If they do that, then everything goes back over TCP and over HTTP2, and they get less and less, right? So this is has to be sort of a careful back and forth as we think about this.
There's also the ossification question about like if they ossify this, then it could break the old protocol.
Understood.
Thank you.
Zahid?
Jahid, actually, before coming to this buff, I was having an impression like, I understand.
Please slow down and get closer to the microphone.
Okay. Okay, I'll skip that intro part. Yes. I don't know if it is question or comment, but I think I heard from Natasha's presentation like this, what is happening now, and what operators perhaps need to do something else. But I didn't get like how many are willing to do so. Like the vendors can provide this as in their hardwares, but obviously it's the operator's decision to turn it on, and that's what is happening for something like ECM, right? So I didn't get the idea like how many of them will here basically say like, okay, this is something really we need, because I really personally I love this idea, like there should be something like this, but and maybe we should do something like this, but I don't know like how many will be turning them on and then trying it out. So that's my actually, it's part of the Lorenzo's problem statement question. Like, so I don't know like if you have any idea on thought, like, because I thought like this was discussed somewhere.
So the more people actually recognize the path impairment, the more people are going to be willing to deploy it. So if there is a set of operators or a set of vendors who have enterprise customers who recognize the path impairment, specifically around things like start-stop semantics, I think that will deploy. Now, how many? Let's say 4, day 1. You know, it's a good estimate. Maybe ETH is 1, and Cisco corporate is 2, and we'll find 3 and 4. But the point is, we can't give you a solid estimate right now because the work isn't done, and the scope of the work may actually affect who's willing. If we went to the key points, remember that there are different potential scopes here, and those of you in line are being asked to comment on each of them.
Yeah.
So this is also not a tiny change, right? It's a larger change. So we have the usual tussle with deployment. It will take some time, and there's one additional deployment incentive for endpoints, and that's that the path layer has to provide some commonalities that we see today when you try to deploy something over UDP. For example, a TCP fallback could be something that is provided in this path layer, and when you now implement your own transport on top of it, you already have it. You don't have to do it on your own. So.
That's TAPS this afternoon, not
So no, but no, it's a question like it's a question what Plus can provide, and it's a protocol detail. We have to decide about it. But it should also make it more easier for new transports to actually get to the pod and get it implemented.
I'm going to just inject a point of order here that we're going to close the section of open discussion at 10 after 12 so that we have a chance to both take the hums and talk about and get the people who disagree a chance to get up to the microphone. So if you're still in line at 10 after 12, you'll have a chance to reclaim your seat. More? Can you I look at the length of the lines. Can you sum up?
Yeah. So my sum up is like should I be hopeful that in 10 years, 3 years of standardization, and
middle boxes that are such thing like IP follow collectors for doing statistics or using 5 tuples to do load balancing.
On the first question, look at draft Kulevin's SPUD use cases section 9. On the second one, yes. But I don't have a reference to the use case for that.
Okay, thank you.
Okay, thank you. Elliot, please be brief.
This is from Jabber. It is Martin Sterling saying, one question. How does the charter recognize the value existing IETF work in this space, namely MIDCOM, NSYS, PCP, etc., especially NSYS, as this is in-path coupled?
So Martin, we hear you, and if you would like charter text that recognizes the previous work, please send it to the list.
I would say the fact that we're having this BOF is an indication that those protocols have not sufficiently solved the problem. Harold? Is that Harold?
Harald Alvestrand. One question and then a follow-up question depending on the answer to the first one. First question, is it already decided whether or not the extra information goes into the same UDP packet as the payload?
No, but if you are in a situation where it doesn't, you have to build a transport protocol for it.
Yes. In the case where it did not, I would have asked about, is this ICE version 2 or RSVP version 2 or whatever?
No, and Joe just said maybe behind me, but I have no idea why.
Yeah, and in the case of yes, I would say I'm worried about your MTU.
Yes, we are also worried about our MTU. This is another reason that we have on the path side. So paths can't make anything on the path can't make anything bigger, and we also hope that we're actually using the MTU problem as a feature to increase the parsimony of this signaling.
Christian.
Christian Wittema. I have a really bad feeling about this thing.
Do we have a Death Star slide?
I ask you about the overhead part.
Order 10.
Well, which is about 5 to 10% of the size of the packet of the bandwidth. That's very significant. Or well, 1%. Okay, fine.
So it is possible that some of the bits that are used here could be used instead of bits that are in other protocols over UDP. So instead of thinking of this as additional, for example, if we're talking about QUIC, right? You could think of this as some of the stuff that's currently spec'd as a part of QUIC, you could think of as being a part of this layer. I'm not saying that that's what we should do.
Yeah,
I'm just,
but
just architecturally a way
but
to.
I believe that's a terrible idea. Because the design of transport protocol is based on principles about what kind of cryptographic robustness you want and things like that. So the moment you have a discrete decision between your transport protocol and some shim layer, you end up with replication.
I would not expect that any of the implementations of Plus would have a fully independent implementation of the transport protocol from the layer underneath it. Another way to think of this is it's not a shim layer, it's simply a definition of what the first few bits of the transport protocols that run over Plus have to look like.
And
so when we say layer here, we're not necessarily meaning you got to call out to this library and then you got to call out to this library.
Also, the next thing that gives me a bad feeling is that you start from a set of use cases, and these use cases mix stuff that is widely recognized, as in, for example, it's a very good idea for the endpoint to cooperate with the routers to defeat denial of service attacks. That's widely recognized. And stuff that is widely recognized as a really bad idea, as in, it's a good idea for the endpoint to tell the routers which movie I'm watching.
I don't think we have content information exposure in the use cases. If there was, then someone has hacked GitHub.
You do not, but you start with a widely extensible protocol that can be extensible for a bunch of things. And I would much prefer to see us start with just the agreed upon use case and something that is narrowly focused to solve that in a consensual way. And then look at whether we can extend.
So we're thinking of this in terms of a very restricted vocabulary, and we have a couple of ways to restrict that vocabulary. And one of the ways to restrict that vocabulary is to require a standards action to add this signal to the IANA registry of these keys. And I don't see a movie content identifier getting past the IASG.
I was doing a caricature, but a lot of what you have, even saying this is video and it is not a video game, for example, is already information.
So personally, I think that this is video versus this is not video is a terrible idea because it doesn't actually tell the network what it needs to know. What the network needs to know is the expected shape of the traffic if it's going to do something to optimize. It doesn't need to know the codec because the codecs are going to change and we don't want to have to go through the standards process every time we add a codec. It doesn't really need to know the frame rate. It doesn't need to know how many red pixels there are in the thing. It doesn't need to know any of those things because that won't allow it to do its job of forwarding the packets better.
But Brian, to be blunt, okay? If the thing is narrowly tailored to a scenario that we really desire, then I would be pushing for doing something like that. If the thing is extensible and can have unpredictable usage, I'll be trying to make it not happen.
That's very useful feedback, Christian.
So if I can paraphrase, that means you're in favor of doing the transport independence of exposure of TCP-like flow semantics, stop. Is that right?
I think his objection is toward other in the fourth bullet.
Okay, that's very useful feedback.
Yeah. Okay, Ron?
Lorenzo Colidi. So I want to come back to something I think it was Brian said, that we're ossifying in order to ossify only once. And then I want to come back though to something that Joe said, which was lots of things can get ossified, not just protocols, but even thought processes and assumptions. Now, what I see here is we are maybe we don't even know that we're doing it, but we're ossifying on a TCP-like semantic with only one path. Okay. Now, one of the use cases in the draft, because I did read it, like I read it in the time, and one of the use cases is explicit signaling of firewall state. Now, if we want to go to a world with multipath, and our devices already have two paths, soon they will have Wi-Fi interfaces, multiple PHYs, and we are going to support that. If we want to live in a world where multipath is common and useful to users, we must support it in this kind of protocol. So I think that this question is so important because a lot of these bullets here and a lot of the drafts have the word path singular, and I don't think we can hand wave our way and say, well, you know, it should say paths, but you know, we're saying path, and we can just change that by adding an S at the end. I think changing from single path to multipath is a fundamental change that may completely invalidate some of the use cases. So my question here is, I would like to see, personally, I would like to see, before we advance, I would like to know if multipath is in scope, out of scope, impossible, a goal, a non-goal. Personally, I would like to see multipath happen, but you know, for some of these use cases, I just don't see how you can do it. You can't do firewall state and multipath and not cause state exhaustion attacks. And I think this question is important enough because it's so fundamental that we need to discuss it now.
So I do believe that it is possible for us to get better multipath approaches into what we're talking about here. I don't think that any of those concrete proposals have made it into the protocol suggestions that have been described yet, either here on stage today or in previous prototypes that we've done. Part of the reason for that is we just had an aha about it this week as we were talking over beer about potential ways of doing that. One of the things that we need to do is to describe that to the group of people who may turn into a working group and see if we think that that approach would actually work in practice. What I'm saying is I don't think it's impossible. I think that there are some potential technical approaches that would lead us to the ability to talk about this in terms of paths early in the process and would not ossify us into the unipath approach anywhere near as early as you might expect.
Yeah, so let me, a question to the BOF proponents, right? So up through nodding of heads, do you think that support for multipath should be considered as a requirement?
Yes, so it's fully in scope, and I even think it's absolutely possible.
Awesome, write it in there.
Thank you. Let the minutes reflect. Blah, blah, blah.
Okay, so we're not even going to hum. We all agree that multipath is a goal?
Yes.
Yes.
Awesome, write it down. Thank you.
Okay. Another management interrupt. Can I see where the blue sheets are?
We have one.
One here.
And
The one
we
over-
might have the other.
Has anybody, who has not signed the blue sheets? Okay, please pass the blue sheets over front. Anybody over here not signed the blue sheets? There. Lovely assistant. I'll take it to you. Okay, Eric.
Eric Nygren. So I think, given we're looking at this being experimental, I think one of the questions I had is whether the charter should be a little more explicit on what the experiment is that we're trying to do. It seemed to me that there are two dimensions that are really critical parts of the experiment. One dimension here is what is the bare minimum we can do to cover the use cases that everyone really agrees on? Because there's a bunch of those that about as Christian was talking to, that like we all agree on, and then, but without really enabling too much of the other stuff, because we're probably, no matter what, as the IPv6 option stuff was showing, even if you add extensibility, we're going to ossify around the stuff that doesn't support extensibility. Like if you start saying, oh, you have to add stuff to a registry to do it, then boxes will start saying, oh, hey, this isn't in a registry that was configured to me 7 years ago. I'm going to drop this packet. So at some point, if we, and I think that kind of the other side of this, which ties into that, is part of the experiment almost seems to be, what are we ossifying onto, and how do you get ossified onto something? Because while we call this experimental, I think the reality is going to end up being that it's going to probably end up being proposed standards track, and you end up with, as people start deploying it, and the experiment is how quickly do people ossify onto an experiment, and what is the set of, and do we just end up with an extra little preface header of 10 bytes that
So if the minute takers could take that text, edit it down, and send it to me for the experimental consideration section of the individual protocol document that I hope to get out sometime soon, that'd be great. And I think that, yeah, it's a no-brainer to put we need to decide what the experiment is in the protocol. Absolutely, thank you.
So we're going to close the discussion off in 7 minutes. So since it looks like there are 8 people, that means the questions and answers are going to take less than a minute each for everybody to get to the line. So keep that in mind.
9 people are in.
Tom, again.
Tom Herbert. So Brian, you said something really interesting, which was that
the goal of Plus is to signal both middle boxes we know about and middle boxes we don't know about. The conversation I would be willing to have between those two could be very different. If I know about a middle box, I may very well trust it, and I may be happy to say, yeah, this is video or cat videos or whatever. Middle boxes I don't know about, it's going to be a lot less that I'm willing to give you. I'm not even sure I want to tell you my TCP connection at the beginning. So pertaining to that in point 4, what I'd like to see is a little more constraints on the signaling and maybe the scope of the signaling. How far can this go? Do I need to signal every device in the network to tell I'm sending a cat video?
Definitely
So
not.
A little bit of scope, a little bit of constraints on point 4.
So the basic idea here is that you want to tell the path something about what you need from the path, whether that's be state or something else.
But
And-
it's not the
and
path.
wait.
In the case of the mobile network, there's a great example. I have a device on a mobile network. The most interesting part for signaling probably is just that first link. So the information that I'm conveying to the network and getting from the network should only be scoped in that context. I shouldn't have to send information specific to my mobile network halfway around the world. They should not be interested in it, right?
So I think that the 2 points I'll make very, very quickly is one, I think as you just heard out there, there are multipath cases here where you may actually be signaling it to more than one. And 2, this is declarative and under sender control. So if you decide that you do not want to send this because you know it will go past a particular hop, then you don't do it. Now, that may mean you use some other, and certainly the mobile networks have this method of signaling what you need on just that first hop. But this is not meant to subsume every other potential mechanism.
All right, but when I send something, I think it's like the DSCP model, drop it.
Tom, I'm going to have to ask to move on.
Stuart Bryan. So formalizing the presence of middle boxes and providing parameters to them, I think is a good idea and is overdue. There's also work in this space going on in the network layer in routing, where we're doing service function chaining to formally steer packets between routers, between middle boxes. I'm not sure whether this path is really a sub layer in transport or a sub layer in the routing layer or a new layer. I think that from what I've heard here, that this discussion really needs to take place between an adequate body of transport experts and an adequate body of routing experts before it can be decided which of those 3 cases this is, and hence how this should be done, and what other parameters are needed. For example, will you need a routing layer to route between these middle boxes? Will you need an OAM layer? Many of these things don't appear necessary to start with, but when you start to deploy them, you discover they are actually needed to make it all work.
So routing is out of scope. That's a lower layer, this function we have, and we don't discuss it here. What's in scope is of course, there's an interaction with the network layer. And so we need experts who know what those middle boxes do and what information is needed here, but I believe we have them in the room, and we try to coordinate this cross layer, which is not the routing, but the int layer, I guess, here.
I'm not sure, I didn't really properly hear that, but
I suggest you follow up with Miria, perhaps after the bar.
Wendy Seltzer, first support for I think Tom and Christian's comments that a more restrictive language is actually more valuable because it doesn't raise the same level of privacy and discrimination concerns. It's less likely to create an extra side channel or more pressure to send these extra data bits, else you can't send anything at all. Remove some of the extensibility bits at this point. Second point was that for an experimental charter, the charter seemed to have some opinionated language in it about the need for this work, and so it could be valuable to tone down, for example, that it's necessary to enable deployment of new encrypted transport protocols, or that this work is necessary to do that, or that signaling must be added to the stack, and maybe we can just tone down some of that to recognize the experiment.
Thank you.
Randall Stewart, Netflix. First point on the charter, I would love to be able to see it say in both user space and kernel space, because I would like to implement this in the kernel, please.
That's what we meant here.
So I want to see it explicit. A point for Brian is a long time ago in a galaxy far, far away when I worked for a large router company, we actually did signal to SCTP, hey, I dropped this packet because there was corruption on the link, on a satellite link. And we had really, really, really good results, by the way. And then finally, I have a question. So I see this quick going on, and I'm interested in implementing it in the kernel, as a matter of fact. I see this going on. So how do you guys see this working out? You guys define this beautiful plus, and it gets out there. In the meantime, the next gen transport, if you will, quick, is defined and doesn't use it. And so this doesn't go out, or does quick not go out? Or do you see quick adopting this, or question?
So we do not see that Quick would have to wait for this. Quick already has facilities of this that are very similar, and that it has authenticated and not encrypted headers and encrypted headers. And so that working group, should it be chartered, will need to decide where that boundary lays for itself. If Quick had been done after Plus were finished, it might have used these facilities, but Quick is not going to be delayed by this work, although I'm sure its deployment experience will help inform us.
I'm going to cut the line in 1 minute.
And I would, if I can be like 5 seconds, I would say even more explicitly that these, if the Plus working group is chartered, these are going to co-evolve, and things that, or no, if the Plus working group is chartered, these will co-evolve, and things that Quick finds out with Plus, yeah, okay. If we have two working groups here, they're going to co-evolve. It's going to be subsets of the same people in the same rooms, and certainly ideas from one will flow into the other.
Joe?
Joe Kulik, Google. So one of the slides said a transport independent way of communicating TCP-like semantics. What if the transport that I'm really, really worried about ossifying even further is TCP? If I want my TCP semantics to change a little bit or grow, do I have to wrap a shim layer and a UDP header on top? Because I think Christian will be concerned about that overhead. But then I saw that you said something there about TCP, or I saw a version of this slide that says TCP. There. So what are your thoughts on TCP? I mean, TCP ossification is something we were worried about. I'd like to be able to hide all my TCP headers and just stick one of these shim layers on.
So I think that what's on this slide is it was at least my cat as a joke. One of the ways you might prototype some of this stuff is to take a transport layer that you know and implement it in the Plus approach, and then compare and contrast the performance, the security, the ossifiability, et cetera. And so, yeah, you could absolutely tunnel TCP over this, and then you get back to Ross's issue from last night of how many times do I have to tunnel. But I do think one of the interesting things that we may learn out of this is some guidance for the people who are writing these sorts of middle boxes and the kinds of things that they should try to de-ossify, right? So one of the things we're trying to get at here is a set of motivations and incentives. And if we can tease those out adequately, we might be able to use this to start making TCP a little better also.
Okay, so at this point, I'm going to close the discussion, and we're going to move on to some hums, and maybe there'll be some time for some more discussion depending on how that goes. So
I'll just hum into the microphone.
Okay, as you wish. Okay, consensus questions. First question, indicate by humming. Do people feel that the problem statement is clear, well scoped, solvable, and useful to solve? Please indicate by humming. Okay. Does anybody disagree? Okay, so would anybody like to take to the microphone? We'll take 5 minutes to expand on why you disagree. Please be brief.
Paul Hoffman, I heard a whole bunch of changes that weren't applied to the charter, but everyone said, oh yes, like the easy one is paths, plural. At this point, the charter is unclear how those would get combined in. If those actually all got combined into the charter, I would have voted yes, but right now, I don't think that it's clear or well scoped without knowing the full set.
Okay. Andrew?
My name is Andrew Sullivan, and that question has so many branches in it that I couldn't possibly say yes. Because getting clear, well-scoped, solvable, and useful to solve with all of the things that Paul just mentioned struck me as a little too hard.
There's 1, 2, 3, 4 pieces. Those 4.
Daniel Kahn-Gilmore. So given that this was scoped as a question of explicit cooperation, I am not convinced that any of this has really done an analysis of who has the power in the relationship between the endpoint and the network. And I believe that this is set up in such a way to make it possible for the network to exert even more power over the endpoint, despite the fact that things will be transparent. I don't think that the endpoint and the network, that their incentives always align, and calling this cooperation when it can effectively be used for coercion, I think is misguided and potentially, it feels like we're saying this one thing, but we're creating something that is an opportunity for another. And that's why I don't think that it's actually particularly clear the way we're framing it.
Can you maybe expand a little bit on how you think that the potential for coercion is worse with this than without it?
I don't necessarily think that it's worse with this than without it, except that we now have an explicit way to say, oh, by providing this information, you're now like, we're just gonna make this mechanism for you to opt in. So for example, a network that says, you may not participate on this network, right? We're gonna send a path to sender response back that says, I'm sorry, you didn't fill in the subscriber ID field. And so therefore we're not sending the traffic. I'm just pointing out that this is like, and so now because the subscriber has opt-in, well, hey, no expectation of anonymity, like we've got this explicit mechanism and you're cooperating by providing it, right?
So I'm going to answer in the GSMA hat, not as a chair hat, because I feel like maybe the presentation I gave maybe crapped all over this, but we have a problem. The problem is network management, not business enabling goals. We know in this community that is not, we don't bring those things to this community, and this community just is not going to support those. We've accepted that. And I'll say we as a wider GSMA community. What we have is a network management issue. What we want to know is what type of traffic or some very, very small piece of information that can help us manage the networks, incredibly small. And then the balance with that is that if we don't get that correct information, we don't gain from it either. So if you lie, both of those sides are disadvantaged. The network's disadvantaged and the content is disadvantaged. So that's where we're trying to get to. So it's not as if we're sitting here saying, okay, we want you to fill in the subscriber ID, otherwise we're going to block all the traffic. We're just like, so that we can manage the network, so that we can just make sure that things run better for the future. We just need to know this minute piece of information to do it. I don't want your subscriber ID. I don't care about that. What I want to just do is make things nicer on the network. That's it.
I understand that you want that, and I appreciate it. However, there may be other operators of networks who have incentives that are not entirely positive.
Can I give an example?
So let's design the architecture so that we ensure that doesn't happen.
This is not that architecture.
Can I give an example of how what he says can happen? Is that okay?
No, I believe you that it happens, but it can happen today.
No.
No.
Can I give an example of how this can make it worse? Okay, here's how this can make it worse. Today, you have an operator that can say, if you don't do this, I will deny service. I will drop your packets. I will make your service suck. Now, what happens is that the host doesn't know why this has happened. And the customer perceives this as an outage, bad service. The customer can then retaliate out of band in other realms. The physical realm, I can complain, I can call support calls, cost you lots of money, go to a competitor, all this stuff. If we build a clean framework for communicating back to the customer, the reason why this happened, and God forbid if we then force implementations to implement that, the customer has no recourse, right? Causing an outage is very punishing for the network operator if they try to exert control. If we have a clean mechanism, that's way worse. Customer gets a lot less power.
How do you enforce the implementation of that? I don't see that. That's the same like you can send an ICMP message.
Conformance tests. Operators have a lot of power. You have to respect this RFC to run on my network.
Actually, Lorenzo is right on this one. The moment the IETF prints a method to do something that is kind of standard, then you change the balance of power. And you change the balance of power when you publish the standard, and you provide a way to do something that can be exploited then that says, oh, I will not accept a phone on my network until it implements that, etc., etc.
Very briefly.
If the vocabulary that goes along with this standard does not include the signal, then it has not published a standard to do so. The IETF has published a standard, IP version 6, that puts 64 bits in the source address. I can force you to do things in that source address. I already have the bits. That is a non-standard use of a standard. If the standard doesn't have in the vocabulary that signal, then the signal is not there.
Yeah.
Let's try to move through the line. There's a number of people who want to get comments in, and we have limited time.
But
I think the point's been made.
Basically, yes, I don't want to reiterate my point too often, but I think that this charter should be way more constricted in just looking at the agreed upon scenario and just solving that scenario and not delving into the quality of service stuff, which is already served by other IETF protocols.
I would add one more point. So we have to decide in the working groups which use cases we want to focus on. The current use cases, where we can't do this in the charter because then we will never get chartered because that was an endless discussion. Like, we should really do it in working group because it has dependencies.
Ted Hardy speaking. That was Miria, by the way. And I'm going to disagree with my earnest co-proponent here and ask the chairs to consider taking a hum that said, if this problem statement were limited to flow state semantics only, would there be interest in the working group, or would there be opposition? Because I believe that...
Okay, stop explaining. Let's do it while it's fresh in people's minds. Nope.
Multipath has flow state semantics. It would still be part of it.
Okay, so let me bind the two together. If the scope of the working group were A, to include multipath, and B, to be restricted to support multipath, and B, to be restricted to flow state semantics, analogous to TCP flow state, and nothing else, would that be agreeable?
Objection. I don't think that's possible.
So we're not gonna discuss whether it's possible or not here. No, we don't have time. I'm sorry. I hear your opinion. So can we hear a hum as to whether that would the group finds that something we're supporting? Okay, and people who are opposed to that. So it's very close, but slightly stronger in favor than against. But okay, let's continue the discussion. I think Mark was waiting. And
I am waiting. Mark Nottingham. The previous discussion was interesting. Standards have power. They add something and create a marketplace. I know that's a controversial position, but let's just take it. And so by standardizing this, we could make new things possible, perhaps. And I'm concerned about that because I don't yet know how this is going to be surfaced to end users. For example, the use cases here are, for example, mobile operators. They often own the handset in many markets. And so something could be inserted without the user's intervention or even knowledge. And so the scenarios that we're talking about that we don't know how this is going to be used. I'm frightened by that, to be honest. There are certainly cases where it's useful, and I understand the motivations, and I don't disagree with them. But there are other places where the internet could change quite drastically, and I'm concerned that we're just going to launch into this without thinking that through. It feels like cookies to me. Cookies seemed like a great idea in 1995 or whenever it was, and look where we're at now. Yeah.
They sucked.
Eric.
Yeah.
Slowly, please. Slowly, please.
So, it seems to me that there might be something hiding in here that is worth getting out somewhere along the lines of what Ted said. We're going to be designing some new protocols over the years, and if we could agree that we're designing some standard substrate layer that encrypts them and doesn't do much else, that might potentially be useful, or not. It seems to, I'm having a really hard time as someone who actually implements these things, seeing much value or probability that I'd be interested in implementing the thing which is designed to communicate to the network, whatever crap people seem to think that we communicate to the network in these to be defined fields. So I guess one question I would ask is, aside from the middle box people, the people who actually transmit the bits, are any of them interested in actually transmitting these bits? Because if not, then this probably isn't going to be very useful no matter how many RFCs we write. Except, you know, for the people who are forced to because the handset makes them.
Yes, hello, my name is Georg Meyer. I'm the IETF 3GPP liaison person, basically coming from 3GPP, so you can kill me after this session. I just want to make a plea for what Natasha said. I mean, obviously there are things that people can be afraid of, that people can do wrong. On the other hand, we are really in need of such mechanisms. And this need won't go away. So we have experience in 3GPP now for 15 years almost in working with IETF. Both sides have had their big amount of considerable pain, but we also made a lot of things work. And I think we should build on that experiences, and we should work together on this to fulfill the requirements, but also make sure that the fears that were indicated here, that they made practically impossible to be realized, right? So I know this is hard. Some people say this is impossible, but we need a starting point, and we need to have communication between the standards bodies that are interested in that. So if you don't start this work here based on a charter that maybe has an additional paragraph in that says these and these are the things we are afraid of, then we can't start communication, then we can't push that into 5G, which is coming up now. So please enable us to have more communication with you, to build on the experiences and to get the work done. Thank you.
So given that we're about out of time, I'd like to give preference to people who haven't had any time at the microphone yet.
Ian Sweat, Google. I mean, I'm really glad we're having this conversation. I think my biggest concerns are you know, DKG's concerns, obviously. But also, there are a lot of people who are very excited about this, I assume middle box vendors, but it's not really clear like which parts they're excited about, because when I go through the various goals, a few of them I have like a little bit of interest in, but a lot of them are, I think are basically unobtainable. Like I think the idea of like closing a NAT hole on a fin, which is like kind of the one I think most people here agree is like useful. I think like the world of like silent close and all these things is probably coming, and there are a lot of radios that just time out and stop transmitting things. And like, I mean, we're already kind of in a world where I think you have to deal with that. I'm not completely sure what the metrics are, but and you know, on the other hand, you have a handshake. We're still talking about TLS. You can still look at the TLS handshake. It's going to look like TLS. So like, we can't like hide that, like no matter what we do. And so I guess the question is like, you know, kind of what we're really getting over just saying like, sure, you can do TLS over UDP. I don't know, in a variety of forms. So.
Okay, thank you.
Tommy Pauly, Apple. Just as far as would people want to put bits on the wire, I think there are some cases I can think of that we would definitely want to do this, you know, regarding this 3GPP networks, cases in which we're doing UDP tunnels, and I think we have very concrete cases in which something to communicate to those middle boxes would solve a lot of our problems right now. So I'm not sure does everything make sense, but I think there is a concrete problem to solve, and I think there are bits that would be useful to send here that we'd be interested in putting.
Yeah, I would encourage the folks who are saying that there might be some wheat in the chaff here to maybe forward some comments on what they think that wheat is to the SPUD mailing list, because it sounds like we need to have some more discussion of this. Go ahead, Colin.
Hi, Colin Perkins. When I think of a path layer, I tend to think of it doing two things. One is helping me find the usable path. And the second is giving me a transparent path. I see this helps in the second of those. I don't see it helps with the first one. And the way it's extensible and the features it provides for making the path, for giving me a transparent path, some of them seem helpful. I'm concerned that it's extensible in ways which are potentially problematic.
Hi, Yoav Nir, speaking as a vendor of middle boxes. So when I'm looking at what kind of information as a middle box I would like to get from the endpoints, it's mostly when does the flow start, when does the flow end, and when does it continue? When does it continue? I mean, if suddenly packets stop arriving, when can I know, intuit that the flow is gone and I'm not going to see any more packets? When can I deallocate my state? And if that was the only stuff that we were proposing to have here, then I'd be all for it. But this seems so extensible, so such a huge space for more and more extensions that without knowing what else is going to go in there, it's hard for me to say that this is well scoped and useful.
Okay. Spencer, we're out of time, so I think at this point I want to hand it over to you to say whatever closing words you want to say, if you want to say any. Or you can head for the exit. He's heading for the exit. Nope.
I'm heading for a microphone. Spencer Dawkins, Transport Area Director in the sponsoring AD for this BOF. I'd like to thank people for coming and thinking and talking. Sounds like there's more work to do here before we can send a charter forward without that work. And I encourage people to continue conversations on the SPUD list. The mailing list still works, even though everybody went to lunch. And your local area directors and IEB members and ISG members care about that. So thank you all.
Okay. Okay, we're done. Thank you.